Thank you for the introduction. I'm Gábor, and I am here today to tell you about my quest to free Chinese characters from the constraints of just being Unicode code points. Um, there are about an educated adult person who speaks Chinese knows about 5 to 8,000 characters. I'm one of the non-Chinese persons who are trying to acquire that script with mixed efforts. So let me start with the impossible, and just to give you an idea of how that even works, give you a crash course into the Chinese writing system in 3 minutes. So I picked a character which I like. It is pronounced Ying, and it means shadow. And I will use this to explain a couple of things. So these characters are made up of strokes. You don't just draw them any which way. You use specific strokes. There are about a dozen of those, like a little vertical line, a little horizontal line, or a hook. You draw those strokes in a particular order. This is all standardized, and this is stuff that you start acquiring when you start acquiring the writing system itself. This character has 15 strokes. If you want to see it animated, this is what it looks like. This is what your pen actually does when you write this character on paper. Now, in a more meaningful level, these Chinese characters, these 9,000 Chinese characters, are made up of components. They have some internal structure. So here I already used colors to highlight two components here. The one on the left is pronounced Ying. It means bright, and its purpose in our shadow character is to hint at the pronunciation. The one on the right, the 3 lines, it can mean a bunch of different things, hair or just stripes or a pattern. Here it is used to mean pattern, and it contributes meaning. So our shadow character is basically made up of, so the way to interpret it is this is something that has to do with patterns that sounds roughly like Ying. So that's how it makes up Ying, shadow. Now this goes on. So the one on the left itself has some more internal structure. Remember, as a standalone character, it is pronounced Ying and means bright. At the top, it has the character for sun, which is literally like a drawing of the sun in an abstract form. And on the right, it has another character, which happens to be pronounced Ying. It means capital city. This is actually the character that's in the second part of Beijing, so like northern city, the capital of China. Um, but the script itself is not a hierarchy, it's a network. So I hid everything else now and just left these components because they combine with other elements of the script in multiple different ways to generate a whole bunch of other characters. So here I gave a couple of examples for all 4 of these shapes. And this is how, using basically a few hundred basic components, the Chinese script is able to generate the thousands of characters that you need to master the writing system. Now, it might sound very straightforward, but things do get tricky. So let's take a look at the capital character, the king character. Um, you might be forgiven to think that it actually can be further decomposed into these 3 components, which really are part of the writing system: a lid, a mouth, and something for small. But it actually doesn't make a lot of sense. How does a lid and a mouth in small give out the meaning for capital city? And it does not. So this is a false decomposition. The shapes are right, but this is not where the character actually comes from. At the bottom, I dug up a couple of depictions of what this character looked like in the past. It was basically a drawing of a tall building, a tower, which was associated with capital cities. Now, the fact is, in order for to make sense of the writing system, you have to have a reliable source of interpretations. And any such reliable source actually has to be based on the history and evolution of these characters. Wu, the language learner. Now, when all of this shows up in Unicode, here's a screenshot from a font editor, FontForge, of our shadow character and its neighborhood. These are just, increasing, numbers. All of this erases all of this interconnectedness, all of this internal structure and relationships. These are just isolated characters now. If you look at how a particular font represents the character itself, it's just an outline. So this also erases the fact that these characters are made up of strokes, that the strokes together form components, and they somehow contribute meaning to this character. So computers, the way they represent the Chinese script, pretty much erase all of the interesting and meaningful things. Now, a couple of years ago, a brilliant person, Shaunak, came up with a project called MakeMeHanza, where he took an open source. So this is a screenshot from his project's website. He took an open source font, which he can reuse, used some really magical, brilliant geometrical algorithms and heuristics to basically figure out where they can be cut into different strokes. Um, that provided almost perfect results that needed a little bit of manual review. And basically, now we have a data set of about 9,000 characters, which go from the part at the top left, the outline of characters, to the strokes that make up the character in the right order with the right directions. So this is a great starting point, but I actually want to go further than that. So what I found very painfully through my own journey to acquire the Chinese script is that there's no digital data set that treats shapes as first order citizens, that describes character components and not just any components, not the naive decompositions that you saw above, but like the meaningful ones, which also help make sense of the writing system and which really annotate all of these components with their function in specific characters. Hey, this contributes pronunciation here. Hey, this contributes some meaning or shape. Oh, in this particular character, this is just a distorted form of something else and it doesn't actually contribute anything. So I set out to create this data set myself. Famous last words, right? Um, I will show you quickly the tool that I built, the workbench, to annotate these characters. I'm starting out from a bunch of resources which I combine, which are available online. And also, all of this relevant information are available in offline sources. This is a scan from a book that I own. This is Rick Harbo's book, Chinese Characters, wonderful book, Genealogy and Dictionary, and a couple of websites and more. Let me show you what the workbench itself looks like. Um, this is the tool. There's a list of the characters on the left arranged by frequency. So this is the numbers here are ranks. You have their pronunciation. The main working area is at the top. I'll show you how that part works. And all the extra information that I've gathered is here at the bottom. So what you can do is, let me recreate part of this character, for instance. So you start from a stage where you just have the strokes, but they are not annotated in any different way. So you can select the strokes. Well, I don't want everything. I don't want these. I say, okay, these together make up something meaningful in the character. This is actually a component that contributes sound. It is actually this other character. And maybe I can even add a little bit of a hint or some additional explanation. And this is how you go on and keep annotating all these different characters. You can see the green check marks. Those are ones that I've already finished. If you scroll further down, there are a whole lot which I haven't touched yet. And you need a way to navigate these 9,000 items. So you can just search or filter by pronunciation, all the characters that sound like this. You can filter by structure. I want to see the characters that, according to the current state of the annotation, which might or might not be correct, contain this component. And this is where I spend a lot of time just preparing these annotations. Back to my presentation. What will the outcome be? When I'm all done with all of this, the outcome will be some sort of a structured file, maybe JSON, which has 1 unit per character. Here's our shadow character. Contains a section for the strokes. These are the SVG paths, the shapes. Some information about the character as a whole. And then a list of the parts, expressing in some combination of, bit vectors, flags. What is the contribution? Does it contribute meaning and sound, etc.? There are about a dozen different possible combinations. Which strokes make up this element in the character? And also, what is the code point if it is actually also a thing on its own? And what are some of the cool uses once you finally have such a correct data set? I will show you 2 of these. I have a prototype for both. So one is a network explorer of the script. Basically, what you can do is go to a character and get a graph like this with the character that I'm looking at in the center. So I use D3.js for this animation. And I see, okay, this shadow character is made up of this Ying character and this Shan patterns character. By the way, this other character also occurs in a whole bunch of third characters. I'm only showing always the top 3 most frequent ones, and I get the highlight, like what they exactly contribute. And of course, you can also navigate this graph. So you can click on the sun character. That doesn't break down any further, but it is part of all these other characters. And then you can go to this one. You also get a little bit of the extra information, verbally or more structured in the bottom left corner. So I think this is just a really, really cool way to present the Chinese script for what it is, a network of interlocking parts. The other tool, it is actually an iPhone app. It's kind of difficult to share my iPhone screen. I'm developing it in Cordoba, so I'm showing the same app in my browser, but just imagine this is an actual app running on an iPhone. I can either paste a character or just draw it. Very often, if you don't know what the character is, it's really hard to type it, so you need to draw it. Because we have the strokes, we can easily build a handwriting recognizer, which is what we have here. There is my character. This is the one that I showed you in the editor. So this is what the outcome looks like in a nice human readable form with some explanations. Again, here's the great advantage that shapes are first class citizens. You can highlight whatever you want and just leave the rest in gray. This is all works automatically. I didn't need to hand draw these things. And of course, you can also navigate this. So you can go into this king character, get its own decomposition. And the really cool part is you don't just see the internal structure of specific characters. You also see, oh, and this one is a sound component in these other ones, which tend to sound like this. And by the way, it contributes some sort of a meaning in these other ones. So this way, you can see each component in context and get a much clearer idea of its role in the writing system. And basically, that's what I wanted to show you. I think it's a really exciting but really huge project. The one question that keeps me occupied now is what is the best way to share a resource like this? So far, this is only private, and with me, I never put something like this out into the world, particularly not while it's still work in progress. So if you've done something like this, if you have ideas or any insights here, do throw those my way along with any other questions. And thank you for watching.